Good evening, sir. So today we are discussing about how to determine the hardness of water. So generally we know that we have to do titration. So before going to that titration part, we must know the basics, the main basics. So now I'm telling about the introduction of quantitative analysis. So what is quantitative analysis? So simply to know the how much quantity of solute in a given solution. For example, 1 gram of NaCl and another solution 2 gram of NaCl solution. So to know the quantity of the solution, we have to use the quantitative analysis. So we are going to know about what is qualitative analysis briefly. Qualitative analysis means simply to know the quality of the given solution, like this is by weighing, no? So then it is, so NaCl, it is MgCl. So it is the quality of the solution. To know the solution, whenever the two solutions are different or same, or which solution is inside the beaker or container, so we have to use qualitative analysis. But from this video we are going to learn about qualitative analysis only. So what is the meaning of solution? Solution is nothing but is equal to solvent plus solute. Solvent and solute. Solvent means, I will give an example. It is a solution of again NaCl. So its solvent is water. So its solute is NaCl. So like this, the sum of solvent and solute is called solution simply. So now we are going to learn about what is titration. Titration means not only experiment, but so what is the principle of titration means to find the amount of substance present in a given solution. So it is the principle, not definition, principle. So it is the principle of titration. Then what is definition means? Simply the mixing of analyte and titrant. So you will get a doubt that what is analyte and titrant. What is the definition of titration means? The mixing of analyte and titrant. Okay. Then what is titrant and what is analyte? So analyte means which is in the unknown solution. Then titrant means standard solution or known solution. So the mixing of this analyte and titrate is called titration. So for the titration, we have to know the three terms. The first one is concentration, and the type of salt, and the volume. Where these three are there means we all know that molarity formula, no? So what is molarity formula? Is equals to weight by gram molecular weight into 1000 by volume in ml. So this is the molarity formula. From this, molarity means the concentration. Weight will be given. So we have to estimate the weight only. Sorry, volume will be given, type of salt will be given. So we have to find the concentration first, and further we will get the weight of the solid, and further we will get the hardness of water. So we will learn further, but we will use these terms in titration. So normality also very important. So its formula is weight by gram equivalent weight into 1000 by volume. So this is also very important. These two formulas we will use in titration method, and another formula m1 v1 by n1 m2. We will use this formula also. So further we will discuss about these formulas. So what is our aim? Firstly, we have to know that okay, molarity formula will be there. For example, how to get the concentration of solution means something NaCl with volume 250 ml and weight is given something 0.5. Okay, then we will get the concentration, no? So we will find weight is 0.5 NaCl into 1000 by 250. So NaCl 58.5 0.5 by 5, sorry, 0.0341. So it is the molarity, means concentration. So from the formula molarity we will get the concentration. So in the titration EDTA method, determination of hardness by the EDTA method, we will use the secondary standard EDTA. Secondary standard EDTA. So this secondary standard solution means titrant. So this is standard solution, means we know the concentration of solution, but this standard solution are two types. One is primary and the second one is secondary standard solution. So this secondary standard solution means the concentration change with the time, so it is not constant. The primary means constant concentration will be there, but this is not constant standard solution. So that's why the problem occurs. So before determine the hardness of the water, we have to determine the concentration of EDTA. So this is the one of the plus problem occurs. So how to find the concentration of the EDTA means we will use the titration method. So I'm briefly explaining. So the determination of hardness. Now the video starts. Determination of hardness of water. So how we will determine the hardness of the water means by using EDTA method. Which EDTA we will use from this method? Secondary standard EDTA. So what is EDTA means? EDTA is nothing but ethylene diamine tetra acetate ion or acetic acid, whatever. So what is the structure? So structure of EDTA means from the IUPAC name only, ethylene means 2 carbon. So diamine means 1s2 diamine, and tetraacetate means this is acetate ion. Tetra means 4 me. So CS3 COO minus, CS3 COO minus. So this is the structure of ethylene diamine tetraacetate ion. So it is an tetravalency. It is an tetravalency compound. So it will form a strong complex or compound with calcium magnesium ions. So it will form strong compound with Ca plus 2 or Mg plus 2 ions, means hard water. Hard water is nothing but the containing of these 2 ions or salts. So in this EDTA method we will use an indicator name EBT. So it is an indicator. So what is the meaning of EBT means? Ureochrome black tea. So it is a salt which is in blue color. So I will teach the structure of EBT also. So what is the structure of EBT means? So the structure is this. This is the structure of EBT. So its IUPAC name is nothing but 1 hydroxy 2 naphthyl azo, దీన్ని ఎజో అంటారు, ఎజో కాంపౌండ్ అని, 2 hydroxy 6 nitro 7 sulfonate. So this is the structure of EBT, which is nothing but area chrome black tea. Next we will also use that buffer solution also. So why we use the buffer solution means to maintain the pH level from 8 to 10. So for this EDTA method we have to maintain the level of pH is from 8 to 10. For the maintenance of the pH level we will use the buffer solution. So that is the things we use in the determination of hardness of water by using EDTA method. So these are the things: EDTA and indicator EBT and buffer solution and calcium carbonate solution or water. So let's go to the diagrammatic manner, but because we are not in lab, so firstly we have to take buffer solution. For example, this is buffer solution. So the pH level must be 11, and we have to take EDTA. Whatever is sodium EDTA. So which is something about which is having 0.05 mole per liter. And we have to take EBT. So firstly we have to add EDTA to the burette. So diagram is not good, I think, but please adjust. So this is the burette. So we have to fill up to 0, which we have to fill means yes, EDTA. I have to fill the burette with EDTA. So after the filling of EDTA, we have to take one conical flask. So into the conical flask we have to take the calcium carbonate solution or water. So we have to pipette out the calcium carbonate solution or water. In the labs we have only 20 ml, but we can use 20 ml or 50 ml, whatever we want. But for the time consumption we have to use 20 ml. So 20 ml of calcium carbonate solution or volume we have to add into the conical flask. So after adding the calcium carbonate solution or water, we have to add now buffer solution. 5 ml. For the 20 ml we have to use 5 ml buffer solution. So after buffer solution we have to use that EBT, which is nothing but Eriochrome black tea, some pinch of powder, or otherwise it will be available in liquid form also, some drops. So after adding the EBT, this solution will convert into wine red color. So after before the titration we will supposed to see the color of solution is wine red. So when we start the titration by this, so after drop by drop or some flow of EDTA, the wine red color will converts into blue color. When the solution converts into blue color, that is the end point on the burette. So how much means converting the wine red color solution into blue solution, that is the end point of the burette. So whatever the volume, for example this 20 means we have to do this experiment for 4 to 6 times. If we get the similar values both 3 or 4 times, so we have to take that value and we have to calculate the values by using this formula. M1 V1 is by N1 is equals to M2 V2 by N2. So likewise we will get the hardness of water. So to determine the hardness of water, so we have to do this all. So from the introduction of quantitative analysis, so this titration EDTA method, what we are using in the EDTA method, so what is the indicator, what is the buffer solution range, and calcium carbonate solution, and the diagram of the experiment lab. So this was the video to how to determine the hardness of water means we have to do this all. So calcium carbonate solution right now, so we are already know that calcium carbonate is the insoluble in water, right? We are always learning this only in the water technology. What means calcium carbonate is insoluble in water, so that's why we are taking the solution and converting into calcium carbonate equivalents, right? So calcium carbonate solution means what we have to do means it is insoluble, right? So we have to dissolve this in the water in the conical flask or something. First we have to add some powder calcium carbonate salt. So after adding the calcium carbonate salt, we have to add 1 or 2 ml of HCl solution. So by adding HCl solution, this calcium carbonate will dissolve in after adding the water. So likewise the calcium carbonate solution will be prepared. And we were discussed before that we have taken that EDTA, secondary standard EDTA, right? So before the determination of hardness, before the determination of weight of the solid, before the determination of weight of the solid, we have to calculate concentration of EDTA first. So after getting the concentration of EDTA by using titration, and then we are going to find the weight of the solute. So and then finally determination of hardness. So this is the process. Hope you will like it. So thank you sir, and thank you all. So now I'm getting off.